Good morning, students. Today we'll derive the equation for depression of a cantilever when loaded at free end. Let us consider a cantilever of length L, and this cantilever is fixed at one end and loaded at free end. Therefore, we are going to derive an equation for the depression of this cantilever. Now, for the depression, there exists when this cantilever is there exist two cases. First case is assume that the cantilever is weightless. First case, that assume that the cantilever is weightless, and the second case is that assume that the cantilever is weighted. We will discuss these two cases for calculating the depression of the beam. First case is that the cantilever is weightless. For this case, we will derive an equation for cantilever is weightless. Now, for this, we have drawn this figure, and in this figure, this is the cantilever shown, that is AB is a cantilever, its length is L, and a load is suspended at its free end. That load equals to mg and is suspended at its free end. Then this depression, the moment of force at PQ, we will consider this PQ for depression. The moment of force at PQ is equal to the external depression moment. Moment of force at PQ is the external moment of force. External depression moment is the external depression moment, and it is given by, and it is equal to W into L minus X. This is the depression moment due to this applied load at the field. But at the equilibrium position, this external moment and bending moment is same. But in equilibrium position, in equilibrium position, the bending moment is equals to external depression moment. external depression moment. And we know that the bending moment we have calculated in previous period, and it is given by y into yz divided by r. It is equals to the external depression, that is w into l minus x. We'll rearrange this equation like this, that is equals to the w into l minus x upon y into s, where in this equation this y is the Young's modulus and I is the geometrical moment of inertia. But we know that the curvature of the beam, we know that the curvature of beam is equals to d2 1 upon r equals to d2y by dx square. This is the curvature of the beam. Now putting this value of curvature of beam in equation 1, therefore this equation becomes d2y by dx square equals to w into l minus x upon y into I. This is equation number 2. For calculating the depression, we will integrate this equation. Now, here integrating equation 2 on both sides, we have taking the integration d2y by dx square equals to integration of w into l minus x d2y by dx equals to y into iz into dx. Here we will take the constant terms outside the integration side and integrate the, therefore d2y by dx square into dx equals to w upon y into iz. This is the constant term. We have taken that constant term outside the integration side, and inside the integration side is l minus x into dx. If you integrate this, you will get dy by dx equals to w upon y into iz. The integration of this l minus x is l x minus x square by 2 plus k1. Lx minus x square by 2 plus k1, where k1 is the integration constant. Now we have to calculate this integration constant. For calculating this integration constant, or to find the integration constant, we to find integration constant to find the integration constant k1, we know that at x equals to 0, at x equals to 0, that is at a, that is at a, depression is 0. That is at a, depression is 0. Means here this, we see that when x equals to the 0, the x is the distance of PQ, this small part PQ from its center to the fixed end. This is the distance. Means x equals to 0 means the depression at A, when load is suspended at its free end, the depression at A is 0, and therefore we put x equals to 0 in this equation, then we get the value of k. Here, as x equals to 0 means theta equals to 0. As theta equals to 0, that is, I can write like this, as x equals to 0, therefore theta equals to 0, that is tan theta. Tan theta is what? Tan theta is nothing but depression along y-axis divided by depression along x-axis, and this is also equals to 0. Therefore, that is why dy by dx equals to 0. Therefore, putting these values in this equation, we'll get the value of k1. Therefore, I write that here this value of dy by dx is 0. Then w into y into ic into the bracket x is 0. Therefore, this term is 0 minus 0 plus k1. This 0 minus 0 will get 0. Therefore, 0 equals to w upon y into ic into 0 plus k1. Means this term also becomes 0, and the value of k1
दोन नंबर ऍड करायचे होते बीएससी फर्स्ट इयर
पिरियड संपले आम्हाला ते करतो ते टेबल झालं गेलं का थोडा सत्याना झालायचं काही तर थोडंफार विचार आता हे बा हे सगळं डिस्कशन त्याच्यात गेलं ना आता हे माझं गेलं पिरियड सगळं कपडं ते थोडं कामाचं सांगायचं त्याला वाद गेली वाढ पुन्हा डबल करेल बसवलं मी सांगू लागलो तुम्हाला तुम्हाला येऊन बोलून राहिले आला